Lesson 2.5 covers logic circuits. One application of logic, and specifically truth tables, is logic circuits. Logic circuits are a type of electrical circuit used in computers and other electronic devices such as cell phones, calculators, and MP3 players. Basically, current flows to the circuit through either one or two connectors called input lines, and current flows from the circuit through a connector called the output line. The most basic type of gates, which are connectors, we call them gates in logic circuits, are the inverter, which is the NOT gate, the AND gate, and the OR gate. Logic circuits follow the same logic rules discussed in previous lessons, but a new notation is used sometimes. Let's look at those notations. We have three gates or three connectives that we're using: the NOT, which is the inverter, the AND, and the OR. In the logic circuit, you're going to see this symbol for NOT, and it looks like a sideways triangle. In our truth tables, the old notation for a NOT, we would put the tilde sign, not P. Well, with our new notation, we're going to use the same symbol, not P. In our pictures for the logic circuits, an AND gate almost looks like a square where the right-hand side is a curved edge. When we're writing this out, our old notation for AND, P and Q, the AND symbol was an upside down V. In the logic circuits, to denote an AND gate, you simply write the P and Q side by side. You don't place any symbol between them. The symbol for an OR is a little bit different. It looks similar to a NOT, where it resembles a sideways triangle, but it's more curved. Our old notation for an OR, P or Q, the OR was represented with a V. In the new notation for logic circuits, the OR is represented with a plus sign enclosed by a circle. In this class, we're just going to focus on translating the logic gate into mathematical symbols. The way I'm going to do these on quizzes and tests, we're going to break these logic circuits into parts. You're going to give me the output for each gate, and then you're going to give me the final output. So let's look at a few examples. Suppose I have this logic circuit. I want to give the output at point A, which is following the OR gate, and then I want to give the final output. When we look at a logic circuit, if you notice, I have three gates. I have a negation gate, and I didn't ask for the output following it, but we're going to discuss it. I have an OR gate, and then I have an AND gate. For the NOT gate, leading into it is a Q. When it comes out, it would be a NOT Q. For my OR gate, leading into it, I have a P, and then I have that NOT Q. Then for my AND gate, leading into it, I have the output from my OR gate, and then I have an R. Each of these lines are sometimes referred to as branches. When you're given the output for each gate, always list the top branch first. This is just going to help us for grading purposes, and also if someone was taking your output and drawing the logic circuit based on that, it would help them know which was first and which was second. The easiest way to begin these is label your three gates. I have an OR gate, I have a NOT gate, and I have an AND gate. So just simply write the words OR, NOT, and AND either inside those symbols or right above them. So we've discussed for the NOT gate, when the Q comes in, it comes out as NOT Q. So if I want the output at point A, look at the gate directly behind it. Directly behind it is an OR. So I know that I'm going to have an OR for my output at A. Well, what is that OR connecting? That's where you look at your two branches. The top branch is a P, so begin with a P. The bottom branch was the not Q, so I'm going to end with a not Q. I connect those with my symbol for OR, which was the plus sign enclosed in a circle. Now I look at my output for my AND gate, which, since this is where my diagram ends, this is the final output for the entire logic circuit. So I'm looking for my final output. It's connected with an AND gate. The top branch traces back to my output at A. So I'm going to take this entire output at A, and that's going to be the first thing I list for my final output. Since that came from its own gate, always enclose that in a parenthesis. That just lets the user know or the reader know that all of that came from its own gate. Now the bottom branch for my AND connector is an R. So I'm going to follow this with an R. And there's not a symbol for AND, you simply place these side by side. This is another reason why I needed the parentheses to show that the Q was with the P connected with an OR gate. Otherwise, it might look like the not Q and the R were the only ones connected with that AND gate. So let's look at the next example. This one's similar to the one we just did. It's just the bottom connector for the AND goes all the way back up to the P instead of going to an R. So let's begin by labeling our gates. I have the OR, the NOT, and the AND gate. So if I give the output for A and the final output, to find the output for A, trace back. Behind it is an OR connector. The top branch is a P. The bottom branch again is the not Q. So I begin with the P, connect it to the not Q with my symbol for OR, which is the plus with the circle around it. This is my output for A. My final output is coming from an AND connector. The top branch traces back to A, so I'm going to bring down the output from A and put it in a parenthesis to show that it came from its own gate. The bottom branch, trace it back and then go all the way up, it goes back to P. So I'm going to follow this with a P. And remember, the AND did not put a symbol between these two. In our next example, I have a P, Q, and an R. I have 4 gates, and then I want to give the output for A, give the output for B, and give my final output. So let's begin by labeling our gates. I have an AND gate, a NOT gate, an OR gate, and another AND gate. So let's begin with our output for A. A is the output for an AND gate. Go to your top branch first. The top branch for that AND gate traces back to P, but it passes through a NOT. So I'm going to have NOT P. The bottom branch traces back to Q. So my output for A is NOT P and Q. And remember, the AND has no symbol, so I simply place these variables side by side. Now B is the output for an OR gate. My top branch traces back to a Q, and my bottom branch traces back to an R. So I'm going to have Q or R. Now my final output traces back to an AND gate. The top branch goes back to the output for A. The bottom branch goes back to the output for B. So I'm going to take my output for A and put it in a parenthesis to show it came from its own gate. For the bottom branch, I'm going to take my output for B and put it in a parenthesis. For the AND, I simply place these parentheses side by side. There is no symbol that goes between them. In the final example, I want to give the outputs at A, B, C, and the final output. My diagram has 5 gates, and I have a P, a Q, and an R. So just to make this easy, let's begin by labeling our gates. I have an OR gate, I have an AND gate, I have a negation or a NOT, I have another AND gate, and my final gate is another OR gate. Let's look at our output for A. A is the output for an OR gate. The top branch goes back to P, the bottom branch goes to a Q. So I'm going to have P OR Q. And the symbol for OR is the plus sign with the circle around it. Next, I want my output for B. B is the output for an AND gate. The top branch traces back to A, so I'm going to begin with the P OR Q with a parenthesis around it. The bottom branch traces back to an R that passes through an inverter. It passes through a NOT gate. So the bottom branch gives me NOT R. So my output at B is P OR Q and NOT R. Next, my output for C. C is the output for another AND gate. So trace your top branch, and it goes back to an R. My bottom branch goes all the way up to a P. I know that the bottom branch doesn't stop at the R or the Q because I don't have a solid point there. I don't have that filled in dot there. So go all the way up till you get to that solid point, and then that lets me know it goes back to a P. So my output for C is R and P. So I simply write this RP. Now my final output is the output for an OR connector. The top branch leads back to B. The bottom branch leads back to C. So it's going to be B OR C. The output for B is P OR Q and NOT R. So put one more parenthesis in front of this and one more parenthesis after it and bring it down. My output for C was RP. Since that came from its own gate, I want to put it in a parenthesis. And then I connect the ORs, I connect these two with the OR symbol, which is the plus sign and the circle around it. So when you're doing the logic circuits, it's all about tracing back, and be sure you use the new notations. Also, be very careful with the parentheses. You always want to put a parenthesis when the output for a gate is used as the input for another gate.